Welcome to the Sheridan College Furniture Studio CNC video tutorial. Computer numerically controlled machines are tools controlled by a computer that move in a controlled fashion in specific directions. Our machine is a Shopbot CNC router, model PRS Alpha 96 by 48, which has 3 axes or directions of movement. Left to right, which is the x-axis, forward and back, which is the y-axis, and up and down, which is the z-axis. Router bits are held by the collet and the spindle, which rotates at high speed to remove material. The spindle is attached to the gantry, which moves over the material being cut in 2 directions. Our CNC router has a maximum cut size of 96 inches in the x-axis by 48 inches in the y-axis by 6 inches in the z-axis. Many types and profiles of router bits can be installed in the spindle, which have standard 1/4 inch, 3/8 inch, and 1/2 inch collets to hold the bits. The CNC router can cut solid wood, plywood, and man-made boards like MDF, foam, plastic, and other types of material. Do not cut any material without obtaining approval first. The CNC router is capable of cutting shapes that include cutouts, recesses, slots, and holes, or more complex forms with relief shaping and carving, but it cannot machine undercuts. In 2D cutting, the Z-axis plunges to a certain depth and stays at that depth while the spindle moves only in the X and Y axes. This is the fastest and most simple form of cutting and normally uses straight end mill router bits. In 3D cutting, the Z, X, and Y axes move simultaneously, allowing complex 3-dimensional forms to be machined. This is a much more complicated type of cutting and requires much longer machining time. Prior to using the CNC router, you must first develop a vector-based digital drawing of your parts in a program like Adobe Illustrator or AutoCAD for 2D cuts, or SolidWorks, Fusion 360, or Rhino for 3D cuts. Or use the proprietary software included with the CNC router, which is Aspire. 2 separate software packages are used with the machine. One is the toolpath generating software Aspire, which allows you to import your digital drawing and create the actual paths, called toolpaths, that the router will cut and translates the toolpaths into G-code, numerical coding, via the post-processor specific to our CNC machine. And the other is the Shopbot 3 control software, which moves the gantry and spindle to make cuts. You must accurately measure the thickness of the material you are planning to cut with a digital caliper prior to developing your part files. Become familiar with decimal equivalents. The CNC router works in thousandths of an inch or thousandths of a millimeter. To use the CNC router, you must sign up online using the Google Calendar. Do not book time on the router until you have calculated all your toolpaths, determined your cut time via the preview function, and prepared your material. For all cuts, you must use a 1/2 inch diameter bit unless you have a very good reason to use a different bit. Circumstances requiring a different bit could include holes smaller than 1/2 inch in diameter, interior corners that need a smaller radius than 1/4 inch, or cuts in 3 dimensions. You will need to enter the specific parameters of your bit when you generate your toolpaths in Aspire. Many bits have been resharpened and are now a smaller diameter. Check carefully with the digital calipers that the bit you are using has the right dimensions for your cut. Turn on the Shopbot by turning the red switch on the front of the electrical panel. Be sure that the panel lock key attached to the studded wrench is in the lock, and the lock is turned clockwise to turn on the spindle. Open Shopbot 3 control software by double-clicking on the desktop icon. If the machine has not been run that day or idle for more than 4 hours, you must run the spindle warm-up routine, which extends the life of the spindle bearings. Ensure that the collet and nut are not in the spindle. When removing bits, please use the rubber mat to prevent the carbide bits from breaking or chipping. Under the Cuts menu, select C5 for spindle warm-up routine with the mouse, or enter C5 in the yellow command line in the Shopbot console dialog box. Press the green Start button on the yellow remote on the top of the monitor cabinet to start the spindle. Ensure the spindle is running. To secure material while cutting on the CNC, you may not use steel clamps or screw anything directly to the spoil board at any time. Flat material of sufficient area can be held by the vacuum to the MDF spoil board. The vacuum can only hold flat material. It has limited ability to hold warp sheets, bowed solid wood, and parts with small surface area. To use the vacuum, make sure that the bleeder valve is open before you turn on the vacuum. Otherwise, the vacuum has to work too hard and will burn out. The bed has 4 zones with corresponding valves. Use only the zones you need and cover the remainder of the spoil board with flexible styrene sheets. Push the green button on the vacuum's electrical box to turn it on. Once you've heard the vacuum power up fully, close the bleeder valve. Remove the key attached to the studded wrench from the spindle lock beside the power switch on the front of the CNC router. This will ensure that the spindle can't turn on when you are inserting a bit. Select the appropriate collet size for your bit and insert it in the spindle. Insert your bit approximately 1 inch into the collet. Tighten the nut finger tight, gripping the bit in the collet, and place the silver offset wrench on the spindle shaft flaps. Slide the studded wrench onto the collet nut from below and tighten the collet nut. Be sure to tighten the nut sufficiently, otherwise your bit may slip down out of the collet, ruining your workpiece. Once you've set your bit, install the magnetic dust shroud to ensure optimal chip removal. Before cutting anything, it is important to zero the Z-axis to your material. To do this, first ensure that the vacuum is on and holding your workpiece flat to the table. Move the spindle over the top of the material you intend to cut at a safe Z height above the material. Remove the aluminum zeroing plate from its plywood holster and place it under your bit. In the Shopbot 3 control software, enter C2 in the command line or click Cuts and select 0 Z axis with Z0 plate, or select the same function directly from the red position pane. Follow the prompts on the screen to lower the bit onto the Z0 plate. Once it touches the plate, it will rise up again and lower once again, then rise again. The Z-axis is now calibrated to your material. Replace the Z0 plate in its holster. You are now ready to cut. Peter, Christina, or a studio CNC monitor must be present when you begin to cut your file, until we are satisfied that you know how to program and operate the machine safely on your own. When cutting a file, you must be at the machine with the stop control or keyboard close by at all times. If you need to leave the machine, you must pause the cutting file with the spacebar on the keyboard and resume the file when you return. Do not leave the machine running unattended unless you have been expressly given approval to do so, as surprises can occur and bits can break. When loading files, transfer them using a USB key to your folder on the CNC router desktop under Student Files prior to running the machine. Select Cut Part from the red position dialog box. Navigate to your part cutting file, select it, and open the file. This will open a yellow fill-in sheet that lists the parameters of the file. Click Start on the red position dialog box. Always turn the spindle on before clicking OK or hitting the Enter key. Failure to do so will start the movement of the gantry without the spindle moving, and will drive the stationary bit into your workpiece, potentially breaking the bit and moving and damaging your workpiece. When your cutting file is running, the best approach is to carry the wireless keyboard as you monitor the machine. Touch the keyboard space bar or left-click on the mouse to pause the file, which you may resume or abort by following the screen prompts. Do this if you need to pause the file temporarily to check the cut depth or use the washroom. In an absolute emergency, hitting the red emergency stop buttons on the yellow remote switch or the end of the gantry will stop the file and all motors immediately. Unfortunately, this will also reset all of your zero coordinates, which will need to be re-zeroed before continuing to cut your file. Neglecting to reset your zero coordinates is not an option, as the bit may drive down into the spoil board, ruining both the bit, the work, and potentially the collet. If you use the red emergency stop, it will lock in the off position. Check this when you restart the machine and turn it clockwise to unlock the stop function. Otherwise, the machine will not run. If the machine is left in this condition, it will potentially confuse the next person who uses it. When you have finished your cuts, use the shop vac to clear any dust and debris from the workpiece that the dust collector didn't pick up. Don't just blow the dust around with compressed air. Carefully lift your pieces from the spoil board. The tabs will hold the pieces together, but they are fragile. Try to support the whole piece as you remove it from the spoil board. If the tabs rip out, they may break and damage your workpiece. This is a significant problem with Baltic birch plywood or other veneered boards. If necessary, slip another sheet under your work so that it is supported as you move it from the CNC bed. Vacuum off the spoil board and sweep underneath the CNC router. To separate your parts from your workpiece, cut through your tabs from the front side of your workpiece with the folding saw that cuts on the pull stroke. This will ensure that you don't splinter out the back of your cut. Use the router table with a flush trim bit to remove the remnants of the tabs from your workpieces. For more thorough instruction on CNC use, you can find the Studio CNC Protocols manual at the computer station. This can be a useful step-by-step guide when you are using the machine. Peter, Christina, and our Furniture Studio CNC monitors are a great resource for more specific information about this useful and versatile machine.